Hello everyone. In this video, I'm going to give a brief description about the my task 4.1. In this video, I'm going to demonstrate my 4.1. So in this, we are going to cover the binary search part. So what we did, and let's see how the binary search works. So if I talk about the binary search, how it works, like if I take a example like a binary search in like I have a dictionary book. So basically, if I'm trying to word like a word fruit. So in this one, how it works like it will directly go in the middle of that book and see the number that the word is comes on the left hand side or the right hand side. If the word comes on the left hand side, so it will throw the right hand side and it start working on the left hand side, and then it start working again, like again it will go on the middle of the left hand side, and then it will again see, and it will continuously work till that the word will not get fine. So let's come on the code, and and we are seeing that the I write the public in binary search the t item in compare. So first of all, we call the binary search on a in a public way, and t item is the item which we are trying to find, like a search, and the in compare I compare is basically used to compare the two things together. So for what the compare means. And if we go further, it will see that our comparer is null or no. If the comparer is null, then it will start because if no any compare is given. So basically it start working on the default way as we know, and we discussed in our 2.1 as well demonstration. In a default way, it starts working on a standing order. And let's go, and in this one next is it will check the count, and if the count is 0, it means that the vector is empty and it will not go further, so it will return -1. So if we have a obviously if we have elements in a vector, so then we will see, then we will provide the index. So basically in the left hands, the left equals to 0, which is our the first element, because in this one we always start from the index 0, and the route right equals to count -1. So the total number of elements should be -1. Like if I have a total number of elements, I have a size of array 10, so it counts from the 0 to 9. And after that, for performing the binary search, it works on a while loop. So how so in while loop, this loop works till the condition is getting true. Once it gets false, the while loop gets stopped. And if it's not be working properly or something it couldn't find, it will directly say return -1. And if we talk about the loop, here we will see like left hand left less than equals to right. What it means, like when left goes past right, it means that the element does not exist. So in this way, like if we see the int mid left plus right divided by 2. So as I tell you before, it will directly go in the middle and see that the number we are basically trying to find is there or no, and it's on the left hand side or right hand side. So once it will go through the middle, once it will reach to the middle, it will go in the end comparison and start compare in this comparison. It will compare the both the number we are trying to find, and if it gets 0, it means like the number we are trying to find is in the middle, so it directly say the return mid. Otherwise, if the number is greater than 0, like the greater than middle, so it will throw the left half. And because we don't need to check, because the number is present on the right hand side, so it will start working on the right half number. And same in the smaller one. So if we have a less than 0 value, it means the it will throw the right half and it starts searching on the left half, because we don't need to check on the right half. And now let's see how it works in our tester file. So if we go in the tester file, here we have a class tester in which we already provide our problem size, which is of 20. We already declared the size. And in this one, we add a manually, we are giving the index 0, adding the number 333. And for the rest of the indexes, we generate a random numbers for them. In this one, we use the 100 plus k next 900. It means it will create for the rest of the indexes, it will create number from 100 to 999. And after that, Um, and as it start working on the vector, because the vector should be null before, and the it will start working on the let's as we work on our test A. So in the temp, we create a problem size from the because we are copying the data in the temp. So what it means like here we do the array dot sort temp new sending order in which in this one we are taking the data in our temp, and we are uh, we are comparing them in ascending order. So because why we are going to do this uh, because the binary search never works on the unsorted array, because if it's work on unsorted data, it because there are more chances to give a wrong answer. And that's why we always work on with the binary search in a sorted data. And after that it will create it and after that it will copy the data, load the data from in our vector. Um from the temp we are taking the data, and after that it will then there we are applying our binary search. And in this one it will like uh, yeah, here we apply our binary search with the ascending comparer, and here we apply the ternary operator. Here we can see the check less than zero, question mark minus one. It will see, it will try to figure out the search for that number we are trying to find. So in this one, and after that in the final we are call the comparer for the binary search. And in this one, if it will with the binary search, like if in this one we are trying to find the number 333. So so basically it starts working on the ascending and comparer. And if it's fine, if it's not able to find that number, so it will directly say fail, and it will give that sign. Otherwise, if it's successfully find that number, it will say success, and it in a test summary it will directly say A. And if there's any kind of chance that if we will get the any kind of exception in our code, so it will stop working on the try, and it will directly go on the cache part, and it will directly say exception. So basically the binary search is very helpful in our sorting to search that particular number or to compare. And it is very easy and frequent way to find a number particularly in a easy and short way. And let's run our task to see like it's working properly or no. So as we can see that our code is working properly in a proper way. So, and thank you so much. That's it. Thank you so much.